In this question, we are given the length of a guitar string. We are told it's 65 centimeters. We are told it is stretched to a tension of 82 newtons. And we are told that it vibrates with a fundamental frequency of 329 hertz. And the question, what is the mass of the string? We know the relationship between the velocity of the wave on a string, its tension and mass per unit length are given through this expression. V is equal to square root of tension over mu. Mu is the mass per unit length. We also know that the frequency of a wave is related to the velocity of the wave through this expression. Now, we also know that at the fundamental frequency, since the guitar string is fixed at both ends, the length of the string is going to be equal to lambda over 2. So through the length of the string, we should be able to find lambda. So lambda here is equal to twice L, which is in this case twice times 65 centimeters. So that's going to be 1.30 meters. That's our wavelength. Now that we know the wavelength, we can find, and we know the frequency, we can find V. V is lambda from this expression here, lambda times the frequency. So it is 1.3 meters times 329.63 hertz. So that comes out to 428.5 meters per second. Now that we know the speed, we can solve for mu here. We square both ends, so v squared is equal to f over mu, and mu then is equal to f over v squared. We know F, that's 82 newtons, and V, 425. So we just solve for mu. I'm going to use the eraser here to get more space. So mu is 82 newtons over 428.5 meters per second squared. This gives us for mu, sorry for writing in different places for the lack of space, 4.45 10 to the minus 4 kilogram per meter. Actually 46 here. Okay, how do we get the units? We have here newtons is kilogram times meters per second squared. So we have the second squared is going to cancel out, and then one of the meters is going to cancel, and we are left with kilograms per meter. Okay, that's mu. So to find the mass is mu times L, since mu is mass per unit length. We know what mu is. The length of the string, we know it, 0.65 centimeters. So we just multiply whatever we find there by 0.65 centimeters. 0.65 meters, sorry. And we should get the result as our mass equal to 2.9 10 to the minus 4 kilograms. In this case, we are given the wave equation and we are asked to label the axis and tick marks if the graph shows a snapshot of the wave at x equals 0. Now x equals 0, that means this part here is 0. So my equation is 2 cosine of 4t. So my amplitude is 2. The label, this is my y. This is my t, is labeled. So my y in unit, whatever unit it is, meters, t in seconds. 4 is omega. And omega is 2 pi the frequency, or 2 pi over the period. In this case, it is equal to 4. So my t is actually equal to 2 pi over 4, or pi over 2. So that's the period. So from here to here, that's pi over 2. So that means this is pi over 2, this is pi over 4, this is 3 pi over 4.